Hello everyone, welcome back to our pre-calculus algebra course online this summer. In this section today, I was talking about section 2.5 about the polynomial and rational inequalities. So the inequalities of polynomial function and rational functions. Okay. The technique that we're gonna show you today is called the sign table that I learned. It's a little bit different. I learned a long time ago. It's a little bit different from our textbook, but I think it's very effective. That's why I tried to bring to you. It's called a sign table. And I claim it's pretty powerful. So. Put somewhere in your notes. I claim that you guys are going to use them again when you get to calculus courses. Alright? So let's start with example. I'm going to go over a bunch of examples today, hopefully help you to figure out the idea of it. Start with the easiest one. Sign table. Okay? The easiest one. The solve for x. Solve for x. And by the way, solve for x in math means you try to find all the solutions, not just one, okay? Every single solution will be found. Say this, x minus, how about x plus 3, greater than 0. You solve x. Obviously, it's very easy, right? All you have to do is subtract the 3 both sides. You got x is greater than -3. So the solution is, in terms of real numbers, by the way, is set of all real numbers that's greater than -3. So you want to write solution in terms of an interval this way, -3, comma, infinity, all right, in parentheses, because we're not including -3. And what about the sign table? If you want to construct a table to see the sign of that polynomial in here, that's actually polynomial degree 1, leading coefficient 1, okay? The 0 of this linear factor x plus 3 is -3. Domain is from -infinity all the way to positive infinity. So you list it that way, and you have the linear factor x plus 3 in here. And of course, when x equals to -3, which is the 0 of that factor, is 0 right here. And you try to test for the sign of that factor. What if you plug in something that's bigger than -3? Say you plug in x equal to -2, -1, or 0, anything that's bigger than -3, you get back a positive number. And similarly, if you plug in something for x that is smaller than -3, say -4, -5, -5 plus 3 will be -2. So eventually you have a negative number. Okay, and this basically called a sign table. What does it tell you? It tells you that the domain of the function, the linear function right here that you have is all real numbers from -3 to positive infinity. And that -3 is a critical value, critical. And actually this is a 0 for that polynomial, okay? And when you plug in values for x into the polynomial, when you plug in something that from -3 to -3, you get back a negative number. You plug in x equal to -3, you get back 0. You plug in some value that's greater than -3 for x, you get back a positive number. So by looking at the table right here, you get the answer for the question. Find all the values of x, that thing is positive. So the answer is -3 to infinity. That's exactly what we have right here. Okay? What if the question I asked you is this? Instead of greater than 0, you have the answer which is -3 to infinity. What if the question I asked you is greater than or equal to 0? Then of course you get the idea already by looking at the table. We're looking for something that's greater than or equal to 0. So positive is good, but 0 is also good. So the answer is going to be square bracket, -3 to infinity. Okay? Similarly, less than 0 will be -infinity to 3, -3 I mean, and less than or equal to 0 will be -infinity to -3 with square bracket. Okay? And since this is a small, very tiny example, you may not see the use of this powerful table. But if we have a more complicated problem with a bigger polynomial or rational function, and the table turned out works very well. Second example. Solve for x, and I have this. X squared minus 4x plus 3 greater than 0. Alright, now we don't have a linear polynomial linear function on the left hand side anymore. What we got on the left hand side is a quadratic. Okay? So we want to solve for this. First of all, try to bring everything to one side, 0 on the other side. This is very important, guys, because if you don't have a 0 on the other side, there's no way for us to construct the table, because all we can compare is to 0, positive, bigger than 0, negative, less than 0, and equal to 0. Okay? So say if they give you something like this, solve for x squared plus 3 greater than 4x. You don't start from here. What you need to do is you subtract 4x from both sides to bring it back to the one that I've just wrote above. Okay? Everything on one side, 0 on the other side. Now let's factor this out. X minus 1 times x minus 3 greater than 0. Okay? So we have two zeros for this quadratic function. X equal to 1, x equal to 3, quadratic function on the left. Okay, so let's construct the table. X, the domain for this polynomial is from negative infinity all the way to positive infinity. And we have two zeros. And we have to list the 0 in terms of increasing order from negative to positive infinity. So 1 got to go first and 3 after. And very similar to the first table, we're going to take care of one linear factor at a time. Let's start with x minus 1. X minus 1 got a 0 at x equal to 1. So when x equal to 1, look 1 here for x, 1 minus 1 equal to 0. When x is less than 0, say x is 0, x negative 1, negative 2, negative 3, any of those numbers subtract 1, you're going to get back a negative number. You try something that's bigger than 1, you have positive number. Okay, I put the bar right here. Just separate between the interval from 1 to 3 and then 3 to infinity. Next, we move on to the second factor, x minus 3. And the 0 for x minus 3 is right here, x equal to 3. And very similar to the first factor, anything that, I should write a 0 right here. Sorry guys. Anything that less than 3, you get back a negative number. Anything that bigger than 3, you get a positive number. Now, what we're going to do is, we're going to multiply the two factors together. That's exactly what we got for our polynomial. Okay? So when x is somewhere between negative 3 to 1, the first factor gives us a negative number. The second factor gives us a negative number. You multiply a negative number to another negative number, you get back a positive number. When x equal to 1, the first factor gives me a 0, the second factor gives us something. So 0 times something is 0. Similarly, when x is between 1 and 3, we got positive times negative, which is negative. X equal to 3, something times 0 is 0. X is bigger than 3, positive times positive is positive. And we just completed the sign table. And then we can answer the question. Okay? In this particular question right here, I asked you, find all the value of x such that this polynomial is greater than 0. So you're looking for the interval that gives us a positive sign. Alright, so let me write in here. For greater than 0, the answer will be two intervals. From negative infinity to 1, union from 3 to infinity. What if I change the question? I ask you something that's greater than or equal to 0. Same question. Change to greater than or equal to 0. And guess what? All you have to change is the square parenthesis to square bracket. Negative infinity to 1, square bracket, union, bracket, 3 to infinity. Similarly, what if I ask you something in here, but the sign is, the inequality sign is less than 0? Now you have to look for the interval that got a negative sign. The interval that negative sign is from 1 to 3. Okay, so this answer is parenthesis 1, comma 3, parenthesis, because we're not including the equal sign. Similarly, less than or equal to 0, bracket 1, comma 3, bracket. Okay. Yeah, this example, I hope that you get some idea of what it means by the sign table and see the use of it to help you to find the sign of a polynomial in general, or in other words, solve an inequality. Okay. One thing, first of all, bring everything to one side, 0 on the other side. Second, factor out the polynomial, and later on, you see we're going to factor out the rational function, and then you construct the sign table. Okay, list out the domain of x, and list out all the zeros from smaller to bigger, and then find the sign for every single linear factors, and you're going to multiply them or divide them all together. You have the answer. Okay, that was the main idea for this section today. Next, let me move on to another example. This time I'm going to give you an example of a rational inequality. Sub x, alright? I got, let me just factor it out. X plus 3 times x minus 1 over x plus 1 greater than 0. So in here, we don't just have a polynomial, we have a rational function on the left-hand side, and we have 3 linear factors. So the zeros for these rationals are x equal to -3, x equal to 1, and x equal to -1. -3 for this factor, 1 for this second factor right here on the numerator, and -1 is for the 0 of the denominator. So we got 3 zeros, or 3 critical values. Now let's construct a table. As usual, we're going to work at 1 zeros at a time. Start with the domain x here from -infinity to +infinity, and not really domain because we have the critical value. That's why I use that word, because -1 will not be in the domain, but it's still a critical value. Okay, all the zeros are the factors. So we got -3, -1, and 1. And then you can work the first factor, any factor that you like, doesn't matter. I'll just write in order. X plus 3, the very first one. 0 is right here, less than -3, I got a negative number, and then bigger than -3, I got positive numbers. Okay? Similarly, I'll move on to the second factor. Let me choose a better marker. X minus 1. So 1 is 0 right here, and then less than 1 is going to be negative, bigger than 1 will be positive, and then the third factor, x plus 1, so -1 will be the 0 right here, okay, bigger than -1 will be positive, less than -1 will be negative. Now I'm talking about the entire rational function, x plus 3 times x minus 1 divided by x plus 1. Okay. So when x is less than -3, this factor gives me a negative number, and negative number. So we take negative times negative divided by negative, negative times negative, positive. Positive divided by negative number is a negative number. When x equal to -3, 0 times something is 0, 0 divided by something is 0. X is between -3 and -1. Positive times negative is negative. Negative divided by negative is back to positive. Now, here comes special case. X equal to -1. something times something is something, and something divided by 0. And we learned before, whenever you divide something by 0, it's going to be undefined. And this is our notation for undefined. It would like two vertical parallel bars saying that we have no value for the function. Of course, we learned in the previous section with x equal to -1, the rational function is undefined. Okay, not on the domain. Here, from -1 to 1, positive times negative is negative divided by positive is negative. X equal to 1, something times 0 is 0 divided by something is 0. 0 divided by something is okay, but something divided by 0 is not okay. Okay? Positive, 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 so this is positive. Now you can answer the question, whatever they ask. So, if they ask you for greater than 0, the answer is going to be the interval with positive. So we have what? -3 to -1 union, what? -1, oops, sorry, positive is a 1 to infinity. If they ask you for greater than or equal to 0, now positive and 0 included, so there's positive and 0 on the left is okay, but not 0 on the right, so we have what? Bracket in here, -3, comma, -1, and parenthesis, because, see, -1 you don't have 0 now. And then union, bracket 1 to infinity. Okay? Positive for bigger than 1, and for x equal to 1 is 0. So 0 to infinity. If the question is, there's a fraction less than 0, then we talk about negative intervals. Okay? So we have -infinity to -3, parenthesis, union, -1 to 1, parenthesis. And then similarly, less than or equal to 0, including 0, so -infinity to -3, bracket, union, parenthesis, -1 to 1 square, square bracket. And -1, I have to use parentheses because, again, this is undefined, but 1 is okay. And via a couple examples that I'll show in this video clip today, hopefully that help you to figure out how to solve for inequalities involving the polynomial and rational functions. And the key that I want to bring to you, the method, is using the sign table. And hopefully this help you to move on to the next levels, is Calculus 1 and then further. Okay, thank you for watching. Any question, please feel free to ask.